Hi dear folks, let's learn the developing a linear programming model with the industrial problem. I will try to simplify your learning. The Callow Fertilizer Company makes a fertilizer using two chemicals that provide nitrogen, phosphate and potassium. So if you have ever done gardening, you must know these nitrogen, phosphate and potassium is mandatory for any fertilizer, and it really helps the new saplings to grow, new seeds to grow into saplings. A pound of ingredient 1 contributes 10 ounces of nitrogen, 6 ounces of phosphate, whereas a pound of ingredient 2 contributes 2 ounces of nitrogen, 6 ounces of phosphate, and 1 ounce of potassium. So you see, nitrogen requirement is given 10 ounces of nitrogen. So you see, nitrogen, phosphate, and potassium. These are the three constraints. These are the three uh, necessary ingredients to follow, because without these three, potassium, phosphate, nitrogen, it will be difficult for any plant to grow. Potassium maybe not, but phosphate and nitrogen would be mandatory. So in that you see a pound of ingredient contribute 10 ounces of nitrogen, and a pound of ingredient 2 contribute 2 ounces of nitrogen. So you see 10 ounces and 2 ounces. I already mentioned you before in the previous questions that the constraints must be together. Like nitrogen constraint of different ingredients must be together. Phosphate constraint like 6 ounces of phosphate in ingredient 1 and 6 ounces of phosphate in ingredient 2. So they are together. 1 ounce of potassium in the ingredient 2. So it is, you see, it is lone. It is only written over here. Ingredient 1 cost $3 per pound and ingredient 2 cost $5 per pound. So you see, cost is there, so it must be a cost minimization function. Cost minimization function is there, 3 per pound, okay, 5 per pound. So X is the pound per ingredient 1 and pounds per ingredient 2. Let's move. The company wants to know how many pounds of each chemical ingredient to put into a bag of fertilizer to meet the minimum requirement of 20 ounces of nitrogen, 36 ounces of phosphate, and 2 ounces of potassium while minimizing cost. So you see, these are the constraints given now: 20 nitrogen, 36 phosphate, and 2 potassium. So, so these constraints must be there. Phosphate, potassium, and nitrogen must be there. So you see, previously we made an equation. Now we we have completed with the right hand side, and you also have seen the minimum requirement. So it must be equals to and greater than, equals to and greater than, equals to and greater than, and the requirement is given 20, 36 and 2. Okay, so that's how the function is done, and we already make the cost function before, and this is a non-negativity constraint. So thank you very much.